So now seminar 7. Okay. Now, and first of all, we will discuss. So we will discuss the following question. It was from seminar number 3, from homework 3. Daniel and Paul asked me homework number 3, task number 3. Task 3. So given a differential equation 3 times cube root of x squared and 2 initial conditions, is it possible to satisfy these initial conditions? As I remember, your question was about the same task or not?
Yeah.
Yes. Is it possible to ask to satisfy these 2 initial conditions? Okay, the answer is the following. So this equation is not if we consider this differential equation, then we can see that this function is not locally Lipschitz. And so the theorem on uniqueness, existence and uniqueness, Picard-Lindelof theory, doesn't hold for this equation. The solution exists but not unique. And if we draw the graph of solutions, we will get the identity solution. And if we solve this differential equation, it can be easily solved because the variables are separated. We can see that the answers will be given by cubic parabolas, as I remember. But the solutions are not unique. If we fix, for example, this point and consider all the solutions of this equation passing through this point, we will get the following. We have one solution which is identically 0. We have a solution which is cubic parabola, which goes through this formula. But we may start with one branch of our parabola, cubic parabola, then goes along the x-axis to some point and go out. So there is also a solution. Okay, it can be. We may try to solve this if you want. Let's solve it. So dx over dt equals 3x raised to the power 2/3. Then separate the variables. Integrate both parts, and we will get, so it will be x to the power minus 2/3 dx. It is x 1/3 over multiplied by 3. Plus the constant and 3t. So we have the following: x to the power 1/3 equals t plus c, and then x equals t plus c cubed. You can see the cubic parabola. Well, and if we want to satisfy these 2 initial conditions, we should start with the branch of the parabola. So x at minus 4 equals -1. So it must be like this. And we may try to find the formula which describes this branch of the cubic parabola. Let's try to find this formula. So we will start with this formula, and step number 1, we will substitute -4 for t, and -1 equals c minus 4 cubed. cubed, right? So C is 3, I think. C is 3. So the formula for this branch will be y equals 3 plus t cubed. So we will go to this point. What is the coordinate of this point? The coordinates of this point? X equals 0. So y equals 0, but what is x? How to compute x at this point? Substitute. So equate 3 plus t cubed to 0. Then t equals minus 3. So t is minus 3. So this is t, this is x. Minus 3. Then we should go along the x-axis up to which point? So step number 2, we will use the second initial condition, x of 2 equals 1. We substitute 1 for x, so we will look at this formula, substitute 1 for x, and substitute 2 for t. C plus 2 cubed, and c is negative 1. And so if c is negative 1, then we have the formula, which is somewhere here. It will be t minus 1 cubed. T minus 1 cubed. It goes through the point 2 and 1. And then this is 1. So the answer is, the answer to this initial value problem is the solution. So colored, there are no colored chalked. There is no colored chalk. So the answer is this solution. It can be described by the formula. The answer can be given by the formula. It is equal to 3 plus t cubed if t is between if t is less than negative 3. It is 0 if t is between negative 3 and 1, and it is equal to t minus 1 cubed if t is greater than 1. Okay, so this is the answer.
So I got until c equals to 3 and t equals to minus 1.
But these two answers can be gathered together, right? And so we can construct a solution or the solution satisfying the initial values. Okay, so in this form.
What if we don't visualize?
So we needn't visualize. So we have the formula, this formula, and we can substitute. So in this way, substitute negative 1 for x and negative 4 for t, and find c1, right? C1, find c2, and then write the answer in this form. So this graph only helps us to maybe to see the situation, the problem, but this problem is solved without this visualization, right? The solution is algebraic.
Yeah, but the 0 part, if we didn't visualize it, how we are going there between
visualize without so if we do not visualize this, we can see that the hypothesis of the Picard-Lindelof theorem are not satisfied. The hypothesis is not satisfied at any point for which x is 0. So not x, right, so this is x is 0, right? So the solution is not unique for any point on the horizontal line on t-axis. Well, and so maybe it is possible to satisfy both initial conditions. Usually it is impossible if the solution is unique, exists and is unique, then it is impossible to satisfy different initial conditions. But in this case, it is possible because the solution exists but not unique. So this is the reason. Well, and now let's discuss systems of linear differential equations with constant coefficients, and we will try to solve the systems. So the plan will be to find eigenvalues, eigenvectors, and then to write the answer, the solution to the differential equation. Okay, we will start with some simple examples. The first example is, so we will solve the following: 3, 2, 4, 1 times x. This is matrix A. Okay, so I think I will solve the first task. Our goal is to solve this differential equation. So the first step is to find eigenvalues. That is to solve the characteristic equation. A minus lambda I is the matrix 3 minus lambda, 2, 4, 1 minus lambda. We need to find the roots of the following equations: lambda squared minus 3 minus 4 lambda plus 3 minus 8. It will be lambda squared minus 4 lambda minus 5. Lambda 1 is -1. I think it satisfies this equation. And lambda 2, by the Wyatt theorem, it is 5. -1 and 5. There are two eigenvalues, and so there will be two different eigenvectors, and they will form the basis. Well, so lambda 1 is -1. Let's substitute -1 for lambda, and we will get the following matrix: 4, 2, 4, 2 times x1, x2. This must be 0, 0. The solution of this vector equation. So we have 4x1 plus 2x2 equals 0, which is the same as 2. Right, so just guess next. v1 will be 1 and -2. Well, next, lambda 2 equals 5. And then we have subtract 5, and we will get -2, 2, 4, -4. So we have minus 2x1 plus 2x2 equals 0. And v2 is the vector 1, 1. Okay, and next, step number 2 and step number 3 to write the answer. Now write the answer. The answer will be x of t, the general solution, is the linear combination of the following vectors. It will be e to the power negative t minus t, right, multiplied by the appropriate or associated eigenvector. 1, -2 plus c2 times e to the power 5t times 1, 1. So this is the general solution. Now, is it clear? Do you want to try? Right, welcome.
But it's something similar to this.
Right, yes. The same, not like Jordan cell, but like this. It will be like this. minus x. Solve it.
We're going to use this. It's going to be minus 5, 9, minus, of course, we do lambda 0, something like that. This will become to be 6, 8, and lambda minus.
Not so minus lambda, because we have minus lambda.
Oh my God! Yeah,
minus lambda, and
minus
minus lambda plus 9. So 9 minus lambda.
Yeah, not bad.
9 minus lambda.
Now we want to multiply this. So this will become to be minus lambda squared. Now minus 9 lambda plus 5 lambda, which is minus 4 lambda.
Not minus lambda squared, but plus lambda squared, because minus lambda times minus lambda.
So then lambda squared minus 4. And then minus 5 multiplied this is going to be minus.
Now minus lambda is correct. And minus 45, correct.
And then minus 8 times 6 is going to be minus 48, but then minus minus, which is going to be plus 48.
Correct.
So we can just do this real quick.
No, not so. Just continue. Not remove.
It's going to be lambda squared.
It's better to check, maybe if you have a mistake. It's convenient to check. Now it's correct. But if you remove some parts, it would be difficult to check if you have a mistake, right?
I'm not gonna, yes. So it's gonna be lambda. Lambda 3, 1. So it should be.
Lambda in the beginning, right?
I'm tired. So it's gonna be 3, 1. We want minus. It's gonna be minus.
Minus 1. Minus. Correct. Minus 1. Correct.
This remember from high school.
3 and 1.
Yeah. So lambda is gonna go. So say lambda equal to 3, and then lambda is equal to 1. Now it's not substituted into this. I want to continue here. It's gonna be easier. So first of all, suppose lambda equals to 3. So it's gonna be. Is it fine if I just write it straight forward? I'm not gonna.
Right.
Типа уже минус 8 написать так.
Right, I think
Not
it is possible.
8, minus 6, 8, and then 9 minus 3, which is
6, right? I usually do this.
It's gonna be x1 and x2 equals to 0. Here I'm gonna go step by step. So it's gonna be minus 8x1 8x1 minus 6x2 equals 0. And then we're gonna have 8x1 plus 6.
The same equation. So one equation is enough. Usually you will get the same two similar equations, right?
So
there.
If I do for only
yes.
That's enough.
Right. Of course, the first equation is enough, because the second one will be similar to the first one. Now solve this. Solve this equation. So you need to find the eigenvector. To find an eigenvector, you need to solve this equation.
Yes, but we have to substitute.
Or to guess, maybe using something. So you need to guess two numbers, x1, x2, both non-zero, so that this equation is satisfied by them.
Guess.
Guess or solve, or what here?
As for solving, I forgot how to solve this.
Okay, why guess? Why I told guess? Because if sometimes you have something like ax1 plus bx2 equals 0. So it is easy to check that this equation is satisfied by the numbers, for example, b and negative a.
Yeah, so maybe x1 can be 1, and then this one can be minus 1.2.
No, I think
Because
not. 8.
6, and then 6 multiplied by 0.2. No,
It is not integer. So you should switch these numbers, and change the sign of one of the numbers, like in this case.
So switch.
So 6 and 8. So the answer will be, I mean, you may take v1, which is equal to 6, negative 8. So switch these numbers and change the sign of one of them.
And it typically works.
So like in my example. Use my example. So this equation is satisfied with this vector.
This satisfies
The same, right? Of course, yes. You may check. So if you multiply minus 8 by 6, right?
Yeah, okay.
Can you see?
Yeah, okay,
well,
then if I go
so this is, or if you, it may be, you may replace this vector by 3 and negative 4, for example. You may divide by 2 if you want, or it is also okay.
So it doesn't matter if here it's negative, it's still about.
Right, of course, yes. So both negative or both positive, it doesn't matter.
But what if one is positive, one is the other is negative? Then it's not going to work?
So you need to switch the sign of either the first coordinate or the second one.
Okay. Okay, thank you. So continue. Okay, now let's work with lambda, which is going to be equal to 1. Again,
Well,
here, so it's going to be minus 6. Minus 6. This remains to be 8. And this one is going to be 8.
Well,
this will go on. You go, as it's going to be, of course, here it's going to be x1, x2 equal to 0, 0. And then we're going to have minus 6x1 minus 6x2 equal to 0. And going by this, we're going to get that v2 is going to be, so suppose this is A and suppose this is B. This is going to be minus 6, 6.
Yes. Or you may divide by 6 and got the vector in the form not equal, but maybe replace them. They are not equal, of course. Negative 1 and 1. Okay, there are two eigenvectors associated with the given eigenvalues. And now you need to write the answer, I think. Write the answer.
Where are you writing? 5p minus p, what is it? So where do we get the 5p? So c1 minus
e raised to the power this eigenvalue. E raised to the power 3t, for example.
The answer in the format of xt. C is going to be equal to raised to the power of
3t multiplied by the corresponding right,
plus e to the power of t multiplied by -1.
And you need to take the linear combination with arbitrary constants, not the sum, but you should include, so the formula must
C1 and C2.
include C1 and C2, right?
Constant 1.
Right, and now it is correct. Linear combination. Thank you. Sit down, please. Okay. So this is Daniel. Well done. Okay, now let's try to solve the differential equation with complex eigenvalues, right? So follow once. Kathy, welcome. I will help you. I will help you. Do not hesitate.
Find out
Well, minus, not -7, not -7, but +7. Uh-huh. Mm. Mm. Correct. Mm. Mm-hmm.
One minus 5.
-16, so 4i, right? Plus or minus 4i.
So minus means square root
Mm-hmm.
4 divided by 2. So
Mm-hmm. Mm-hmm. Right, 2i. Mm-hmm.
now
Correct.
eigenvalues.
Uh-huh. Eigenvalues now.
And also
Mm-hmm.
eigenvectors.
Yeah. So you need to do the same, just
Mhm.
just the same. Substitute, and you will get complex. Uh-huh. You may use this part of the blackboard. Mm-hmm. 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 Correct. So, but you need not find the eigenvectors for this eigenvalue because they will be complex conjugate, and it is enough to find the eigenvector for this associated with this eigenvalue, and then after this, according to theorem proved in the proved last lecture, we will take the real part of the resulting of the product and the imaginary part. Just you may take one eigenvalue, find an eigenvector, multiply them together, and take real part and imaginary part. I will help you, but so we need not do this. Mm-hmm. Mm-hmm. Well. Mm-hmm. So there are two equations. Are they the same or not? So let's try to check. So the first equation will be minus 6 minus 2i times x1 minus 4x2 equals 0. And the second one will be 10x1 plus 6 minus 2i times x2 equals 0. Are they the same? Are they proportional or not? How to check this? So I suggest divide by 2. both. I suggest to divide both equations by 2.
Okay, so this is
3 plus, not 2i, 3 plus I, just I. 3 plus I, and divide, and remove minus. Well, 3 plus I times x1 plus 2x2 equals 0. And the next will be 5, 5x1 times x2 equals 0, right? Are they the same? Difficult to decide. Maybe
no, we can multiply by make one of them real.
Right. So multiply by the conjugate by 3 minus I.
So I'll multiply the second one. By
3 plus I.
Yes. This is 9 plus 1.
It is 10.
And this is
5 times 3 plus I times x1 times x1, x1 times x1.
So
But if we divide, this is 10, and if we divide by 5, then
yes, we get exactly.
Okay, right. So two equations are proportional, and this is a good news, right? Because because this means that there is no mistake in this. So we need to solve just one of two equations, or guess the vector. 4, right? Or maybe divide by 2. So look at this equation. So it will be 2 and negative 3 minus 3 minus I. 2, the first component will be 2, and the second one minus 3 minus I. It's okay. Well, this is an eigenvector. What shall we do next? Do you remember?
It will be just a
conjugate, right? And this vector corresponds to the conjugate eigenvalue. But how to write the solution to the differential equation? So you should remember that we need the real solution, not the complex solution. Okay, stop talking, boys. So for the complex solution, we may take the linear combination of these vectors, but for the real solution, we need to take the real and imaginary parts of what? Do you remember? So the real and imaginary part of e raised to the power lambda t times v1. Okay. So what is e to the power lambda t?
We have to take the
lambda
so
t
is 1 plus 2i.
Substitute so e to the power 1 plus 2i t plus 2ti times the eigenvector 2 minus 3 minus I. What is it?
Can
It's,
expand this one.
e to t times, you may write times cos and sine. Cos of what?
So plus
cos 2t, correct, plus I. Right, and multiply by the eigenvector. 2, negative 3 minus I. Well, next we should perform the multiplication. Multiply this number by each component of this vector. and take the real part of the resulting vector and the imaginary part. And
what do we do with the imaginary part?
Imagine, so the imaginary part is the part, so for this complex number, this is a real part and this is an imaginary part.
I know what is
and
the imaginary part. What do we do with the imaginary part? Как используем?
So, first of all, let's multiply, and after this, you will have two vectors, the real part and the imaginary part. And in the answer, you should take the linear combination of these two parts. This is the idea.
Okay.
Right? So not plus, this is the other component. So if you multiply this by 2, it will be the first entry, so the first component of the new vector. 2 cos 2t plus 2I sine t. And the next component, right, this is a column vector. Not plus, but this is another component of this vector. Right, multiplied by that's I, correct.
Here only needs simplification.
1 minus 3I plus 1, correct.
Yes, so we just need to.
So the real part and the imaginary part, and now you also need the real part and the imaginary part. And the second component, right? Minus 3 cos 2t, and plus sine 2t, correct.
Over here, minus cos 2t. Here
minus 3, minus 3. Correct. Right, and this, right, these two vectors form the basis in the solution space, and for the general solution we need to take the linear combination of them. Well, yes, this is the answer. Thank you. Sit down. Yes. Okay, well, now we may what happened to what? Sorry? I or I can't see. E raised to power t. Yes, yes. So we need to add this. Yes, of course. Yes, e raised to the power t. Thank you. Right. Who wants to be the next? Maybe Rohan. Rohan, welcome. So you will do the same as Kefir. So next seminar we will have a control work. So yeah, it's time for the control work. So Rohan, you should exercise. Welcome. Нет, слушайте, нет. So no. So it's time for the control work. Now we need to have a control work. Well, task number 4. no. So it will be 5 minus 6. 3 minus 1 times x. Let it be this. 5 negative 6. Well, try to solve. The first step is to solve the characteristic equation.
What was the formula again, Kaki?
4 multiplied by 23. 4 multiplied by 23. Divided by 2.
Put the determinant sign. That's crazy.
Okay.
6 and 4 multiplied by 23. So maybe it's better to do the following. So root of 36 minus 4 times 23, it is the same as 2 times root 9 minus 23. I think it's, is it? So it is not minus 5, it is 5.
Oh.
5, right, and then it is negative 5. So let's fix minus 5. Then it will be minus 5 lambda plus lambda squared, correct? Then and minus 4 lambda, not plus 6, minus 4 lambda.
18 minus 5.
13. Yes. Yes, 6i, correct.
3i.
Divided by 2. And the first, the real part is not 2 but 1. If we divide 4 divided by 2, yeah 2 plus or minus 3i, right? So the eigenvalues, write down the eigenvalues. 2 lambda equals 2 plus or minus 3i. Next, what shall we do next? Matrix, right, and eigenvector. Five minus 2, 5 minus 2 minus 3i, correct, minus 6, 3, minus 5, minus, right. Just subtract 5 minus 2 is 3. 3 minus 3i. Mm-hmm. What, what does it mean? Minus 9, minus 9, minus, or a. What is
multiply.
Multiply. Minus 9, minus 9i, plus, all right. And the last is minus 9, plus 18, correct.
Minus 18. So it's 0.
Okay, 0, but we didn't know. Right, so the determinant must be 0 because it follows from our construction. So lambda was found so that the determinant of this matrix is 0. So you have checked that it is actually 0, right? But now we need to find the eigenvector, not to check that, that the determinant is 0. So he has checked that the determinant is actually 0. Therefore, so sometimes maybe it is useful to check yourself.
How can I guess? I cannot guess.
How to guess? So just first divide by 3. 1 minus I times x1 minus 2x2 equals 0. And the first idea is to switch two coefficients and change the sign. So if you want to, Rohan, if you want to solve something like ax1 plus bx2 equals 0, so this equation is satisfied by the following vector. You should switch the numbers. So b, a, and change the sign of one of them. For example, minus b or minus a. So you should switch and change the sign of one of them. 2 and 1 minus I, correct. So this is an eigenvector now. And next, you should multiply. You should do something like this. E raised to the power lambda t multiplied by this eigenvector. 2, 1 minus I. Right. And you should substitute 2 plus 3i for lambda. 2 plus 3i, because lambda is 2 plus 3i. Well, then you should right. So what is e raised to some
Sine 2 sine I.
2t? It is e to the power 2t times so not in the power but multiplied. So 2t, it is correct, but times cos 3t plus I sine 3t. And multiplied by your vector. You should fulfill the multiplication, and after this take the real and the imaginary part of the resulting vector. What does it mean? So it must be a vector. A vector. It is a vector. And it must be I. So I sine 3t. Okay. I sine. Minus or plus sine 3t?
Minus.
I times minus I will be plus 1. If we multiply I by negative I, we will get plus. It must be plus.
And then?
Simplify and find real and imaginary parts of this vector. Show that this is a vector. Use brackets. Multiplied by e to the power 2t. Sine 3t. Maybe so each of the term must be multiplied by e to the power 2t, or you may take it out of the vector.
Oh, exactly.
So so divide by e to the power 2t. Right, and write it here. Next, you must take the real part of this vector and the imaginary part, and the answer will be their linear combination.
So the 2 cos 3t plus this one plus this one, that's okay.
Right, without I, right? So remove I, multiply by some constants. Can it be seen? So is it clear? Wow.
Or should I play instead of?
Right. So what's the problem?
So instead of I, any constant?
So no. You must do the following. Just a moment. Let's write the answer in the form C1 times e to the power 2t times the first vector, which is the real part of this vector. It must be 2 cos 3t plus sine 3t plus sine and I plus sine 3t, and then plus c2 e to the power 2t times the imaginary part, so it will be sine 3t and sine 3t minus cos 3t. Okay, so now it's okay. Thank you. Okay, is it clear? Okay, the question is, what shall we do next? Maybe we have time for a break, but after the break, shall we discuss the Jordan cells? Because so we have some problems concerned with Jordan cells. Maybe I can show you how to solve these problems, but maybe
For 7 or 6 last seminar, I remember we were solving the question and we couldn't solve it fully, or we couldn't solve it to a point where we didn't understand what was happening. And I saw the seminar 6. I tried to solve it yesterday.
Discuss seminar 6.
Well, not seminar 6, but how to solve the second part. So like the part where, remember last seminar we were talking about, and we went into here.
I see.
Question, because I tried to do it and I couldn't understand as well.
Well, let's try to discuss. Let's try to discuss seminar problems from seminar 6. Yes, but let's have a break, and after this we will have we will discuss seminar 6. I have changed the tasks from seminar 6. So it seems to me that the end of the last seminar was too complicated for you. So solution of the last tasks from the preceding seminars included 2 steps. The first step was to use Liouville's formula to find 2 linearly independent solutions of the homogeneous problem, and the second step was to use the method of variation of variation of variables of constants, variation of parameters, right, to find the solution of the non-homogeneous equation. But it seemed to me that step number 1 was too complicated, and so I have changed the tasks. So I give the answers to step number 1 and your goal is to complete the solution, right? So now the task will be the following. So task 5 from homework 6, from seminar 6. And the task is, given the differential equation x greater than 1, so x okay, so step number 1 was to solve the homogeneous so the associated homogeneous differential equation with 0 in the right hand side. So it was too complicated. So the Liouville's formula used to solve it, but it was too complicated, and the plan was to guess one independent solution in the form e to 2x, right? It was step number 1, and next, using this so this solution of the homogeneous corresponding associated homogeneous equation, we need to apply the Liouville's formula and find the general solution. But now it is given. Let it be given. Okay. And now we will use, so now I have changed the task, and the task will be given the solution of the associated homogeneous equation, find the solution of the non-homogeneous equation using the method of variation of parameters. So to complete the solution, we need to reduce first, divide by the first coefficient, and reduce our equation to the form y2 primes minus 1 plus x divided by x y prime plus 2 times 1 minus x divided by x y equals 9x e to the power 2x. And then how to solve this non-homogeneous equation? So the idea is consider the parameters C1 and C2, the constant C1 and C2, to be the functions depending on x. And so to represent the solution as C1 depending on x times e to 2x plus C2 depending on x times 1 plus 3x times e to negative x. And substitute this solution into this differential equation. Okay, so there is the algorithm, how to simplify the computations. Okay, and we have discussed that this can be replaced by the following. So from this form of the solution for the non-homogeneous equation, we should consider the derivatives of C1 and C2. We will get the linear equation for derivatives of C1 and C2, and it will be in the form C1 prime times the linearly independent solutions times e to 2x plus C2 prime to 1 plus 3x times e to negative x equals 0. Okay, it comes from this, right? Just take the derivatives of C1 and C2. And next, the second will be take the derivatives and differentiate these functions times 2e to 2x plus C2 prime and differentiate this. And we will get so just I will differentiate it. It will be 3 times e to negative x plus 1 plus 3x times negative 1 e to negative x, and this will give us 2 minus 3x times c to negative x. Equals the right hand part, 9x e to 2x. And we need to solve this linear equation, and our first goal is to find the functions for C1 prime and C2 prime. Right, let's try to solve this. Maybe we can easily eliminate C1 prime if we multiply the first equation by -2 and add to the second equation, and we will get the following. So C1 prime will be cancelled, and we will get the following equation: 2 minus 3x minus 2 plus 6x times e to negative x equals 9x e to 2x. I think it's this. It is the same as 3x e2 prime e to negative x equals 9x e to 2x. Then from which we have c2 prime equals 3e to 3x, and so c2 is equal to e to 3x plus something, right? Plus c2 tilde. Let it be c2 tilde, because so we should involve the constant must be included, right? It's this.
Tilde is the constant.
Because we integrate this, so to find c2 prime, c2 we need to integrate, and so c2 prime is constant. So this is not a constant, this is a function depending on x, and c2 tilde is a constant now.
Okay.
Well, and next we need to find c1 prime. To do this, we may substitute this into the first, for example, into the first equation, right? We will get the following. And to substitute 3, it will be from which we have C1 prime equals minus 3 minus 9x. And C1 equals minus 3x minus 9/2x squared plus C1 tilde. And the answer will be y equals, okay, C1 of x is given by this formula, minus 3x minus 9/2x squared plus C1 tilde e to the power 2x and minus x, right? And C2 1 plus 3x e to the power negative x. Okay, is this. We can simplify this if we want. C1 tilde e to 2x plus, so if we multiply this, we will get 1 plus 3x times e to 2x plus C2 tilde 1 plus 3x e to negative x. And we can find the sum of these two terms. And this will give us the following. If we find the sum, we will get 1 minus 9/2x squared e to 2x plus C1 e to 2x plus C2 1 plus 3x e to negative x. Now I will check the answer. Am I right? Maybe not. So no, it is not correct. No, it is not correct. Why I don't know. So 1
But
by
algorithm
1.
itself is correct.
Yes. Okay, so 1 can be included in this. So 1 times e to 2x can be included into the constant C1. So we can remove 1 and change the constant. Or maybe 2 tilde. But this constant is also not correct. So I will try to check. Just a moment. Maybe to just try to differentiate. 3 minus 1 minus 3x, right? This. Just minus. Think minus, right? Because we multiply by negative 2 and subtract minus. Then we have minus 9. Then we have should remove 3. One-third. C2 is 1/3. And after this, we must remove this. And then minus x minus 3/3. Okay, 3/2 plus 1/3. Next, so if we multiply this, we will get times 2x 1/3 plus x plus C2. It is correct. And after this, we will have the following. It will be 1/3 minus 3/2x squared. Okay, and now it is correct, right? Because 1/3 e to 2x can be moved here, right? And so it is the same as minus 3/2 x squared e to 2x plus c1 2 tilde e to 2x plus c2 tilde 1 to plus 3x e to negative x. So now it is correct.